It's an opportunity to hear Ian Jackson talk about the influence of geology on the Romans and their Norman frontier.
Thanks very much for inviting me. Thanks to Sant for being supportive and associating with the geologist in producing the book. And thanks to the many archaeologists, several of whom are here, without whom it would have been impossible for me as a geologist to write this book. I'm not blaming them for the archaeological content. It's all my own work. It's just that I plagiarized a lot of theirs too. In the context of archaeology, my subject, geology, is marginal. It's not that you don't consider it, you do, but you don't understand it, just the same way as I don't understand archaeology. So we have a communication gap between us. And in large part, the book is written to try and mend a bit of that gap at least, or at least alert you to the fact that there is a gap. And one of the reasons I wrote the book really is to heal it. And it's a book for lay people. It's one in the middle there. You'll see I'm on a book selling spree at the moment, but Sant benefits from the sales ultimately. It's a book for lay people. It's a coffee table book. It's a coffee table book that deserves a shaker coffee table, but it's a coffee table book nonetheless. And it's also a book for specialists. It's a book about archaeology that people in my discipline can understand. And it's a book for you. It's a book about geology that archaeologists can understand. Because to be brutally frank and Cumbrian, it's readily apparent that you don't. And I think you're missing opportunities to enrich what you do, and more to the point, opportunities to constrain some of the things that you say. But we'll come to those. So I guess the easiest thing, if this works, try the mouse, try the clicker. Right. Because here's my conclusions. I put them first in case you're really, really bored, and you can get to the end of the talk and you can discuss it in the pub or the coffee later and you'll know what I said. So here they are. My thesis is that geology has a profound influence on the way the Romans took decisions about the infrastructure on their landscape and the materials that they use for their possessions. And if that follows through, this is going to be fun. I didn't do that. Help, Richard. There you go. I'll just keep it there. What I'm trying to persuade you is, within your reduced budgets, save a little bit for a geologist, because we can help. And don't assume that by recruiting somebody with an OU degree in geology, or somebody like me who's a Carboniferous and Quaternary specialist, to look at Ordovician, Langdale hand axes, that you're going to get a good result. We're a broad field. So when you pay your money out, make sure you get the right expertise. So the next 40 minutes is going to look like this. A little bit about archaeology and geology. 2 minutes to put you on the same page as me, 485 million years. And don't say I'm not fair. We're going to do your discipline in 2 minutes as well. Although I appreciate that could go back 2.6 million, but let's just say. And then the core of the talk is about the influence of rocks on the Romans, basically to try and provide a bit of evidence for those brash statements up front. And then some questions, and hopefully I'm hoping for some discussion. Kind, nice, constructive discussion. I asked, I did my degree in Newcastle. I was born in Carlisle. So whatever way you look at it, I've spent 74 years associated with this red line across the country. I've probably seen more of it than most of you, I guess, if only from the train line between Newcastle and Carlisle. And I now live in a Roman marching camp at Barden Mills, so a Roman temporary camp, sorry. Get the terminology right. I had an honest job for 20 years. I was a field geologist in Cumbria and in Northumberland, producing British Geological Survey maps, 1 to 10,000 maps, the definitive maps of the geology of the UK. And then I climbed the greasy pole and became a director of BGS, and my responsibility was information and delivering what is now called digital transformation, delivering the geology of the UK in a digital form. So you could get all of the maps of BGS and all the boreholes on your phone. And then in 2011, I retired and I came back and we moved back to the Northeast. And my wife told me I was being the grumpy geologist I told her I wasn't going to be, and I ought to get out more. So I started to write books. I've just worked out it's a wheel, and when you turn it, it goes backwards. Yeah, geologists. So what do we share? What hangs us together, really? Well, we all look at the past. It's just that you only look at a little bit of it. And we observe, we survey, we measure in the field. Your stuff is really high resolution. Mine less so. We even share terms, stratigraphy and provenance, and they work. We just got to remember that the scale is somewhat different. We use techniques. Our geophysics is much bigger than yours. We go down 7, 10 kilometers, but admittedly, it's much cruder resolution, and the things we look at are much cruder. But we use geochemistry too, as do you. And a lot of the work you do in terms of isotope work or looking at bones and teeth actually goes to one of the labs in the place I used to work at. And the biggest thing we've got in common, to be honest, is that we're interpretive sciences. Based on whatever facts are available, we make a stab at interpreting and coming to a conclusion. And always remember that that's what geology and geoscience is. And please do remember that even if you send it to an isotope lab, it's a best estimate based on their experience and the sort of chemistry they're doing. You mustn't take it as fact. You must look hard at the samples, and you must even look harder at the expertise of the people who are doing it. Where we differ is that what we do as geologists, what I used to do, is focused on rocks and the processes. How did they get there? And then I don't just want to understand what the rocks are and where they are and how they got there. I want to see how that, what the implications and impacts are for hazards and for resources. Whereas your focus is trying to weld humanities and human interaction with the landscape. And I guess that's a really difficult challenge, to attempt to bond the humanities and science is not easy. And the result is that human variable means you create a lot more narratives than geologists do, than scientists do. And I envy that richness. I envy the fact that if you count up the TV programs, there are many more archaeological programs than there are geological programs. So all this is born of envy. Basically, you're great storytellers, and people are really interested because you're dealing with an, albeit dead, animate subject, whereas my subjects are all dead. and they don't move much. So what I'm going to do now is just quickly, in a couple of minutes, put us all on the same page. 500 million years. My body length plus my arm and my finger is 4.6 billion years. Proportional. We're going back 500 million there. From the tip of my finger to there is 500 million. That's as far back as we're going. All of this, we're not going to consider. I've just rubbed off the human part of that. It was less than the width of the white bit on the end of my nail. I don't say that to diminish archaeology. I say that to diminish the arrogance of humans who think we're the best species since sliced bread, and we're incredibly small. So I didn't do that. That was a pleasant geological 2 minutes, wasn't it? I mean, you'd be hard pressed to. They always told me when I did a presentation course, you can either be funny or you can be full of novel science, or you better have something attractive. So that was something attractive. So how do we tell the story of the landscape, our bit? Well, we have a stratigraphic column, a stratigraphic table you're familiar with, and then we produce pretty colored maps that you've all seen as well, and they portray the spatial disposition of the rocks. We go one better than that nowadays. We produce 3D models, 4D if you include time, and 5 if you include uncertainty. So that's where the science is at the moment. But for most people, it's just a pretty colored map. I mean, do any of you watch Digging for Britain?
Yes.
Almost everybody, except those who switch off. Have you ever noticed when she takes people to a tent, Alice, there's 2 easels at the back? And did you notice what's on them? Geological maps. Not because they're relevant to the story, but because they're very pretty. So this is a real geological map. It's what the country's made of. Little 1 to 10,000, 25 square kilometer squares. A much lower resolution than archaeological investigation. So our minimum size of a deposit is 10 meters by 10 meters, which is crude. But there's a big difference. It's available for all of the country. Consistently available from the Shetlands right down to the Scilly Islands. All over, you can get a geological map. You can't do that in archaeology. What you have is a piecemeal variable distribution of highly detailed work, which means you've got some big gaps to fill in and some big conclusions to come to, deductions. So one can complement the other here in certain ways. I hesitate to do this, but there's the geological column on the left-hand side, and I've filled 2.6 million years of it with some from with the archaeological timescale. I don't know whether 2.5 million is right, but it's what I read in a book. I've also put some figures against Mesolithic and Neolithic and Paleolithic. I appreciate that those are not fixed. Trouble is that most people like me who are not archaeologists started up thinking they were fixed. But they're diachronous, I guess that. They happen at different times in different places, and they're subject to argument. And guess what? So is the geological timescale. Just that we deal with bigger chunks. So 100 million years here and there, well, who cares? I really debated whether to put this in because many of you are, this is your business, this is your bread and butter. I'm teaching Granny to suck eggs here. But a question for my pains, I'm a voluntary guide at Houstead's Fort. I do try and tell the truth, honestly, and not extemporize too much. But the second question everybody asks is, what was the landscape like when the Romans arrived? And that, everybody thinks it was Sherwood Forest. They honestly think it was a complete forest cover. Partially because when they look north, all they see is Wark Forest of Sitka spruce spreading. So they think it was all like that. But it wasn't, of course. And the ice only melted 15,000 years ago. And then we had tundra and periglacial conditions for 3,000 or 4,000 years. And then Mesolithic people came back and full woodland cover, maybe, maybe not. What about all those animals that were eating all the saplings? Maybe they opened it up and it was more steppe than woodland. I do like the uncertainty of this. And then transition to Bronze Age, because who said it all happened at the same time everywhere? And why didn't they practice the same things together? And the real point, this is Warden Hill, as you well know, the real point about that question that the tourists ask who come to Houstead's is that the Romans didn't come in here and invent everything. First of all, it wasn't Sherwood Forest. Secondly, there were people who already understood intimately what this landscape had to offer in resources and protection. And the Romans must, too strong a word, may well have, entirely plausible, that they gathered that intelligence from the indigenous people. So again, a slide, I was hesitant. So let's say they came to Carlisle. I'm a Carlisle boy, so I'm very proud that their first centre was Carlisle, but I'm going to claim it anyway. And then they began to build the wall, and I was really relieved that there is no agreement about exactly whether it was 120 or 122, and you can use the same pieces of evidence to argue for both dates. I love it. I love it. Just the same as geology, but nobody tells you that. On the lines on all my geological maps are sometimes plus or 10 meters, plus or minus 10 meters, sometimes plus or minus a kilometer. If I tell you I was the guy who mapped Western Newcastle and Kenton before the A1 bypass went in, and the minute they drove those cuttings through, my map was rubbish. So I'm used to this uncertainty, and you know, if my word processor, if it had keys that wore out, perhaps, probably, maybe, approximately are all words that are overused. So let's get to the meat, the evidence for those statements at the beginning. These are some of the things that, very small writing, but I hope you can read it. The pictures help. So those are 48, not 50, for those who are doing the calculations quickly. 50 things that are in this book, and there is no way, even with the best will in the world, I could entertain you for 50 different geological sites. So I've chosen 14. And then the first plug for the book, you can always buy it to find the other 36. So let's do the first one. I really hesitate to talk about this in front of some of the people here, but the red bit is the wind sill. The other coloured bits are, the blues are Carboniferous, and the fawn is Triassic, and the pink on the left-hand side is the Permian. And the red bit is the windsill, and the windsill is an intrusion. It's dolerite. It's very hard. It makes an upstanding north-facing scarp of about 30 meters for around 30 kilometers in the central area. From what I've read, my wisdom is received, that this was from Mr. Graf Stahl and Professor Briest have written that this would define the line on the wall across the Solway-Tyne Isthmus. And the other two bits between Sewin Shields and the east coast, and between Greenhead and the Solway, were simply subservient. They simply stayed on high ground, kept away from the wet bits, and maintained a view into the Tyne Valley where that was appropriate. So the windsill gave the Romans a natural strategic advantage. So I'm going to score 1 for geology there. Without the windsill, they wouldn't have built the wall here. Without the windsill, there'd be no monks sitting on Holy Island. Without the windsill, there'd be no barons in their castles at Dunstanburgh or Bamburgh or anywhere else. So a piece of hard rock that resisted erosion and made a profound lump in the ground that gave strategic advantage or position was fundamental to both Roman archaeology and medieval. Let's go to the Vallum. That little picture over there is Milking Gap, looking west. The diagram across the top, the map across the top, the red bits are the windsill, and the brown bits are peat, which were probably lakes in the Roman era, or at least much less well drained than they are now. You can notice the dots that as everybody knows, the windsill follows the Roman wall, follows the windsill. The Vallum adheres closely to the wall until you get just about to Sewin Shields. Then it disappears off to the south and then wobbles about a bit, in and out, avoiding the hard dolerite of the windsill. They tried that at the four-wall ditch at Limestone Corner, come on, Windsill Corner, and they struggled to dig it. They didn't do that again. But they also must have realized that digging through peat or lake sediments was going to be a Sisyphean task. The minute you dig it, the sides would fall in. After all, it's what, 10 feet deep and 30 feet wide? It's going to collapse. So the logic is, let's avoid those things. And all the way from Sewin Shields to Covoran to Magna, that's what they did. And if you notice, they even did a little kink around the little peat bog at Magna, which is now drained, but you could see it on the first geological map. So there's the second piece of evidence. Geology influenced and defined the line of the Vallum in the central sector. Okay, this is thanks to Mike Collins, who took this picture, I think. It's the wall at Buddle Street, Segedunum, and it collapsed contemporaneously 4 times, allegedly. And the archaeological papers say it collapsed because of water. No. If this had been on sandstone, you could have had the Tyne behind it and it would still have withheld it for a while. This is a really small stream coming in from the north. Water was, if anything, simply the trigger, the catalyst. The wall at this point, they got to Newcastle and then they decided to extend it as a bit of an afterthought. So that last few kilometers east goes across laminated clays. So those are glacial clays that were laid down in glacial lakes 20,000 years ago, very, very fine grained. When there's a summer melt, you've seen Moraine Lake in Canada, a bit like that. And those clays have very low shear strength. How many of you have been held up on the A1 at the moment at the bottom end of the Team Valley? How long have you waited for that flyover to be built? Why do you think all those enormous great piling machines have been there and it's cost 280 million for one interchange? Why are there only low-rise buildings in the Team Valley? Because there's 40 meters of this stuff. Well, there isn't 40 meters here, there's a lot less, but it doesn't change its engineering capabilities, which are that it won't support load. Now, maybe the Romans knew that because from what I've read, there are double strength foundations, double thickness foundations beneath this line of wall. But the reason the wall collapsed was because of the low shear strength of the clays. It wouldn't have collapsed if the bedrock had been something competent and hard. This is a quaternary thickness map. We don't use the word drift anymore in geology. We use the word quaternary, or superficial is okay. Drift is not okay. So if you're just about to do your PhD and you've written the word drift, do a global. This is a quaternary thickness map. The pale colors are bedrock. The lighter grays are thin drift deposits, and the dark grays are thick drift. It's generalized, very generalized, but the point it makes is that from here to here, the wall runs pretty on bedrock or pretty close. And then you get somewhere here, which is near the Irvine, near Williford Bridge, so Bird Oswald's here, things start to thicken up amazingly. Two things happen. One is you can't find the sandstone near the wall anymore. You've got to go into the river valleys, into the Irvine or into the Eden or the Gelt or the stream south of Dalston to find stone. That means a bigger transport cost and a much less efficient build process. So the logic is that if all I've got from this point on, and whether they had to expedite this piece of the wall, I don't know, but we'll just use what we've got. After all, using earth, turf, and wood wasn't something that was unknown to them from elsewhere in the wall's length, the frontier of the empire. They used whatever they had locally. So from this point on, they built a turf wall or an earth wall. And it was only at the times of Septimius Severus, later when he rebuilt it, and perhaps more immediately near Bird Oswald in Hadrian's reign, that they started to rebuild in stone. But their first attempt was just an economy of effort. It was the principle of least effort. Let's build it with what we've got. The principle that seems to have been applied when they needed stone for the wall was they would grub out small quarries as close to the wall as possible. Transport costs would have been their highest input. You will know as well as me that in the east, it's grey-brown Carboniferous sandstone. And in the west, it's Perma-Triassic red sandstone. Carboniferous is 330 million years old. The other stuff's 270 million years old. Lanercost Priory, you can see, which is robbed stone. You can see the line of the difference in sourcing stone immediately. Just another plea. You've dropped the word drift. Thank you very much. Don't use the words red rock fault. There isn't one. It's an unconformity. The Perma-Trias steps over onto the Carboniferous without a fault. So It's not that these things offend geologists, they just mean that they take everything else less seriously when they read it. It's like using the word volcanic for the windsill. It's not. It's intrusive. So I know I'm going to get stick for this later, but you're taking me out for a meal so I can stand it. These are small things, but they kind of set off signals about how serious you are when you take on board somebody else's science. And I hope it works the other way, but I'm sure you'll tell me. I ought to go back there. Can I do that? Yeah. So a point that you had a fairly major heritage lottery project recently that attempted to source the stone from the wall and define where it came from. It was doomed to failure. It was doomed to failure because the sandstones that provide the stone for the wall are not unique spatially or in two and three dimensions. And that fact was known to expert geologists long before that project. Basically, and the reason for that is simply paleogeography. You're looking, the source of the Carboniferous sandstone are huge rivers coming out of a mountain range to the north. They're across I'm not talking the Thames here, or even the Rhine, I'm talking the Amazon or the Brahmaputra. They're braiding and anastomosing across a huge plain, working and reworking sand all the time, billions of tons of it, and then reworking it again. So that none of these sandstones that you see in the Carboniferous have anything unique about them that can pinpoint a signature here. I don't care if you are using PRXRF, you still can't do it, or even thin section microscopy. It's not possible. The only time it becomes something worthwhile is when you've got incredible archaeological control and incredible geological proximity of that resource. So I'll give you an example. Some of the sandstones in Vindolanda and the sandstones on the fell at Barkham Fell, there's some really close association, but you can't do it. And if you switch, what about the red stuff, the permatriassic sandstones over in the west? Different paleo environment. There you're talking about a desert plain with transient lakes. The permatriassic sandstones there are water lane. We've got, sometimes they get exposed to the air and we've got rain spatter, raindrops we can see. Sometimes we've got ripples in them, so we know they're water lane. But we're talking almost 300 meters thickness of this stuff, spreading all the way from the Eden Valley all across to the west coast. Billions of tons, reworked and worked again. So there's nothing unique about them. So any attempt to try and say this stone came from this quarry is setting itself an almost impossible task, except if you've got that proximity and peculiarity of the sandstone in local, then you might have a stab at it. One of the most things were a surprise when I researched this book, because I thought I knew about the wall and I found I knew nothing. And the more I read, the less I knew. And one of the things that puzzled me was I always thought the wall was mortared. And then I read that maybe it was in its first incarnation. Maybe it was puddled clay. Trampled clay, sorry, puddled clay is a different thing. Maybe it was laid dry. But nonetheless, eventually it had mortar to stick it together. So where did it all come from? And when I did the research, I could only find 3 definitive kilns, and one of those was at Rochester and only just been found. There was one at the Nag Burn, which was being excavated in the early part of the 20th century and is now covered up. The the question is, the Romans would have needed millions of tons of limestone and then millions of tons of quicklime to make into lime mortar. Where did it come from? And I know there's somebody at Sheffield who did some research who posited that maybe it all came from one giant kiln somewhere in the east. I'm not sure that works for the same principles as taking the sandstone from a long way. It makes more sense to make the lime where you need it. So maybe the reason why we're not saying any Roman lime kilns is that they use clamp kilns. So this is a running kiln. They kept it rolling. They kept it fed with coal or charcoal and little chunks of lime and lit it and then dragged out the lime from the bottom. But maybe they just dug out 4 by 2 meter depressions in the ground, piled fuel and then piled chips of limestone on top and made the dirty mortar they wanted that way. It's a mystery. Alan Rushworth told me that there are things beside the Housesteads Visitor Centre that they never did explain that might well be. There's a PhD here for somebody. Where's all the lime come from? So that's one of the differences between us. See, I look at this and I don't think, I know I should, I don't think about the narratives that could be developed in terms of the society and the politics and what the quartermaster was thinking and all those other esoteric things. My head says, wonder where they got that from. Where's the provenance? So maybe you can apply for a degree in the geology and the archaeology departments and get a grant to find out where all the limestone from. Here's this thing gets increasingly contentious, this presentation, or increasingly wobbly, I guess. There are many fabricae, okay? I did Latin for 5 years, I failed. Along the wall, many forts have workshops. They're all using iron. They're all smithing iron. So, I'm a regular visitor to the Great North Museum. I look in all the cases. I look at Vindelander, all of those things, seeing all those iron objects. And this simple brain says, wonder where they got the iron from. So I ask a few people, archaeologists, and they say, well, they're using bog iron, of course. So I said, can you show me some places where they got it from? And they said, no, of course we can't. It's all been drained. You wouldn't expect to find it now. Right. That doesn't go down well with a scientist. So I said, well, if you go south to near Selby, you can find places where they were harvesting bog iron and they were smelting it. We've got a guy called Peter Halkin from Hull. I hope he's not here. Has done research. And I said, that's fine, but that's 180 kilometers away. And one other important point, why would you use do you know what bog iron is? Okay, so bog iron is, you've got water that's enriched with iron. There's that reddy brown stuff that's coming out of coal mines and filling up Whitehaven Harbour at the moment. It comes into the vegetation in a swamp or a bog, and it flocculates and then collects and coagulates around the roots and the plants. And then the water table drops and it creates iron pan. And people who go find it can go down with a rod and they hit a hard pan. Right? That's bog iron. So at best, it's an incredibly impure resource. It's only about 25% iron. And it's very, well, pretty hard to find. And I guess it's not easy to extract. And the other point is that in the Northeast and in the Northwest, we're lucky enough to have primary geological sources of iron in the ironstones. Now, you know them best from Consett, or Shotley Bridge, or Bellingham, or Reedsdale. You know all of these places. I mean, some of them produce enough iron to make one of the Tyne bridges. And their iron ores are called siderite. They're carboniferous. They're 330 million years old. There used to be there used to be concentrations of iron on the seafloor that have created layers and nodules. And they can be up to 40% iron, maybe even 60 in some parts, really rich. And they're heavy. And they occur 300 meters north of Vindolanda. They occur less than 200 meters south of the fort at Corgap, of the wall at Corgap. How do we know? Because 18th, 19th century iron miners have dug huge open cast pits and then put wagonways in to feed a blast furnace at Haltwhistle. If you go down Bracky's Burn, which is the stream that runs just to the north of Vindolanda now, there's a meander scar, an erosional scar. In it are huge ironstone nodules. You can't miss them. And that natural exposure will have been there in Roman times too. You can't even mistake them in your hand. Their specific gravity is much higher than a normal rock. So there's this local primary geological source. Go over to West Cumbria, you've got an iron ore called hematite. The basis of Southwest Cumbria's industry for goodness knows how many years. It's deep red. You can't miss that either. If you ever go walking in the hematite country, you're going to come back and your shoes will probably be ruined. They'll be deep red. Try going to Egremont, you'll soon find out. Some of those hematite deposits, the veins and the way it takes over limestones, and they're thick, they're rich, and they're very near Hardknot and Ravenglass forts on the way through in Eskdale. They're so red that the Romans must have noticed them, or if they didn't, then the indigenous people must have done. Okay, so maybe they didn't use any of those, bog iron or siderite. Maybe they imported their iron from the Weald, because there is definite proof of Roman iron mining and smelting in the Weald and in Northamptonshire. Guess what the ores in the Weald are? Siderite, the same as the ones we've got here. I'm not saying it's right, but it's entirely logical because we don't know. All I'm asking is that the default answer isn't bog iron when there are other options. And I think there's a second PhD out there for somebody. Where did all the iron come from? Ooh, now we're getting really contentious. So this is Whitley Castle, supposedly cited to make sure that Roman state protection of the lead and silver industry was guarded. Could have, of course, just had a bunch of unruly Cumbrians up at Ulster. They haven't changed much. So it had nothing to do with the lead mining at all. The fact is that lead is incredibly popular. I mean, you go to any museum and it's just full of objects that are made of lead. And there is no prima facie evidence that the Romans mined lead in the Pennines. But almost everybody thinks that the circumstantial evidence is so great that they must have done. We just haven't found it yet. We haven't found the wooden shovel that they find in Cheshire or the other artifacts that they find in the Great Orme at Llandudno. But here we haven't found them. But we know there is a lot of lead, and we know they use it for everything from coffins to pipes to eyeliner to sealing water tanks at housesteads. So we know that we're using it, and it makes absolute sense that they were using local lead. But don't assume that geologists can, with the answer to a maiden's prayer, and tell you where that lead came from. We can tell you what its composition is isotopically. So we can tell if 3 lead bullets from Burns Wart were the same. But don't ask us to tell you with any degree of certainty where it came from. And the reason is we haven't got a big enough and comprehensive enough and high resolution database to say that lead came from the Pennines or that lead came from the Lake District. We've got a Venn diagram that is wonderfully loose without enough statistics to say anything more than it's plausible, possible, but the word probable, no. So even high tech isotope work is not necessarily going to solve your problems. And I think you must always quote the error bar that comes back from the geochemist that reports your results. Can't get away without talking about silver. The geological evidence for silver mining is slight, which is a word that actually means pretty much non-existent. The Pennines, the North Pennines, are silver poor, not silver rich. There are very few places where the silver bearing figures would get to 40 ounces per ton of lead metal. Normally they're about 8 or 12 in most of it. In the whole of the 18th and 19th century, 100 years of mining in the 18th and 19th centuries by the two main mining operators produced 150 tons of silver, sounds a lot, for 1.5 million tons of lead metal. It's not a lot. So you can say, well, the Romans needed to take the lead out, to silver out, to improve the quality of the lead, because otherwise it would be less easy to work. You could say that. You could also say, well, they had free labor. Soldiers who were doing nothing needed to make work. There were prisoners, there were slaves. You could say all of those things, but all of them would be special pleading. No evidence to say those things. It's kind of finding a justification for something. The fact is that the North Pennines are silver, despite the fact that we've got the Corbridge Lanks and really nice. How do we know they just weren't one-off specials? After all, they're not abundant. So the geological jury is out on silver. The coal, though, now we know it was used along the wall. It was probably transported from the northeast down to the Humber and down to the Thames. But where was it mined? And there are instances of huge coal stores at Benwell. There was a bunker at Housteads. People have been really kind, because this is the one area I'm about to do a deep dive and get some of this coal tested to see if we can provenance it. So we know that it exists at Corbridge, at Housteads, at Vindelander, at Magna. All these places have coal. It was really well used as a fuel. And the good news is that it's one of the few things that geologists can actually say, yeah, we can tell you where that came from. And the way we do that is looking at the little tiny spores, what equate to pollen grains. But it can't be pollen because the trees were still producing spores at that time. So it's little spores. If we can tell you which layer the spore came from, then we can tell you which coal and which geography that coal came from. At the moment, there are only, in the 60s, a very eminent coal palynologist did some tests of 5 samples, and all of those, and they were from Vindelander and Corbridge and Housteads, and they all pointed to the coal coming from somewhere in West Durham, say Ebchester-ish. Well, that's a 30+ kilometre haul. And you've got coal on the doorstep at Vindelander and at Haltwhistle. I mean, the little limestone coal was the thing that actually initiated and supported Barden Mill, Haltwhistle, Acomb, Alston. All of those are underlain by an older coal called the little limestone coal. It's only 250 meters from Vindelander to the little limestone coal at Barkham Fell. Surely they were using that, but we don't know. So that will be a proof of concept that, I mean, as this says, just think of the narratives that could flow from understanding where that coal came from. A question for you. Everybody knows that until 60, 70 years ago, there wasn't a farm along the wall that didn't have its own domestic peat digging. Peat we have in abundance. Peat was used by Neolithic people. It was used by Iron Age people. It was used up to 80 years ago. It occurs so close to the wall. One turf was found in a 4th century in a 4th century context in York. So we know they were capable of using peat, but it's a really difficult thing to prove, I guess, because what are you looking for? Heather? How does it differ from that in the organic remains? But I did hear a whisper that Magna might have found some evidence of peat burning as a fuel this year. But you are drawn to the T.S. Eliot quote, aren't you? It's not so much as we haven't found it, it's that we haven't looked for it. So a challenge. Were the Romans using peat on the wall? After all, it's the biggest source of fuel we have. Getting a bit obscure now. I learned two new words. Armchair voussoir. I know some of you know well what it is. How's everybody else? Is this the first time you've ever heard of an armchair voussoir? Right. An armchair voussoir is one of these blocks here. Thank you, David Mason, if you're in the audience. One of these blocks that makes up an arch that supports a roof, usually in Roman bathhouses, I guess. And whichever Roman engineer specified it, might have been Vitruvius, I don't know. These things tend to be specified to be made with tufa or tuff, not to be conflated. Physically, they both serve the same purpose. They're lightweight and they're easily carvable. But tuff is volcanic ash that was well known around Vesuvius, whereas tufa is a modern limestone of the sort of stuff at Knaresborough, at Mother Shipton's well. It just precipitates out of spring water because they've got high concentrations of calcium carbonate. And when it's soft, it can be carved and notched. And if you notch it, you can slot clay tiles in and make a cavity in the roof. And this here, I'm feeling I'm ignoring you on that side. Sorry about that. But this here is an armchair voussoir leaning against a bathhouse wall at Chester's. And above it is a big block of tufa near Newbrough, in the burn at Newbrough near the supposed Staingate fort. Shamefully, geologists don't tend to map tufa in the north. It's because it usually occurs in blobs of less than 10 meters by 10 meters. So you have to ask the individual geologist, did you spot any? And it does occur further south. It's called puffstone. So Shropshire, Worcestershire, you get whole churches built of tufa. It's a really popular building material because it's lightweight. Tufa was probably used in the bathhouse in the Nag Burn at Housesteads because John Hodgson saw it there in 1820 something. And so these blocks of these armchair voussoirs all down the Nag Burn. Well, I haven't found one, and I've been severely cut and bruised trying to find it. But I haven't found one. But if you go to the replacement bathhouse in the 3rd barrack block down, in the entranceway, you find 3 blocks of tufa just used as rubble in the stone. So I wonder whether they were just retrieved when they rebuilt the bathhouse. So my cry is, for those of you who are involved in rescue excavations or excavations on the wall, if you see something that looks like a weird limestone that's full of holes and porous, don't stick it on the discard pile. Tell me about it. Because obviously, tufa was pretty important to them. This is a bit Cumbrian. This is a roof tile made in a place called Scalescuff, about 7 or 8 miles south of Carlisle on the old Roman York Carlisle Road. 25 kilns, turning out tiles stamped by the famous Legion of the 9th and the 20th Legion that went on to cover the roofs of Carlisle. So you can go and see this one in Tully House. And that picture over on the right is a clay pit that we're digging ceramic clay out of in the 19th century in Carlisle, one of many. What amazes me is that they were using stone-free laminated clays, the same thing that caused the wall to collapse at Buddle Street. They were using those stone-free. There's only the place where the 25 kilns are, there's only a square kilometre of this laminated clay. How did they know? How did they know it was there? There's a fort at Rhea near there, but was it the indigenous people who or was it when they were just driving their road up between York and Carlisle, they happened to think, "Ooh, this is a bit of dodgy ground, but I'll remember that when we need a bit of clay." So I'm always amazed how they managed to source so many things. This over here, no, I'll do it this way because I'm feeling I'm blighting you. This is 6 meters of gypsum, calcium sulfate, CaSO4. You know it best. It's here, look. Plasterboard, British gypsum. That's what it is. That was this quarry, this mine at Cock Lakes near Carlisle, but it also occurs at Kirby Thor, it occurs in West Cumbria. Gypsum is a valuable multi-use mineral. So it has a crystal form called selenite, which is used in windows in Pompeii, and alabaster, which is its decorative layered form. You can make vases and ornaments out of it, and the Romans did. And it occurs all over Cumbria. And we know, for those of you who are not Roman specialists, but go a bit deeper and older, will know Thornborough they found gypsum crystals in the subsoil below the turf. And the assumption is that the whole of the ringed henges at Thornborough were coated in gypsum, which then was dissolved and then is recrystallized again as fibrous gypsum in the soil beneath. So we know that Neolithic people were using it. This is a scan of one of 45 burials that they found in York in the 19th century. They'd just been scanned by Professor Carroll at York University. Interestingly, they thought this was one body before they scanned it, and now they can see parents and child. The burial technique is to shroud in cloth and then pour liquid gypsum or plaster of Paris. Plaster of Paris is just burnt gypsum that's then you pour water on, hydrate it, it sets quickly. It is a burial ritual that is not unknown, but it's usually high status and it's found on the continent. And my question is, gypsum would have been a highly visible substance here in the north. It occurs near Thornborough Henge in the River Ure. It occurs in the River Eden near Long Meg. It occurs in West Cumbria. Did the Romans use it? I couldn't find any record of them using it in the north. So either I've missed something or they didn't. These are from the recent excavation in Carlisle. There are now 60 or 70 of them, I think. They're intaglios. Anyway, they're rings with little reverse carvings, signet rings. And they're made, typical again. My first question to a guy called Martin Hennig, who's the British expert on intaglios and gemstones, was, where did they get them from? Because they're made of silica. They're made of what a geologist just call this stuff chalcedony, but gemologists and jewelers have all nice names like jasper and cornelian and agate and things like that. For us, just it's a silicate. So I said, where are they from? He said, I don't know. Do you know? And I said, well, I know where I can get some jasper. I can get it in any stream coming off the Cheviots or on the northeast coast. Collect bits as big as your thumbnail, which is as big as some of those things. This little thing here is only 3 mil across. So the question is, were they importing these things from the continent, from India, from somewhere else? I know I know I'm really boring. I keep coming back. Where did it come from? But think of the stories that where it comes from tells. And then Martin asked me, well, what would you need if you wanted to test one? I said, I'd probably need to drill a hole in it. And then we stopped the conversation. And, but where where is I bet you didn't know there's a place called Carnelian Bay on the North Yorkshire coast. So these are questions, boring questions, and we could tell where they came from, but we fall foul of the same problem. I consulted a prof in the University of Siena who does this stuff. And she said, well, even if you could get an identity, a signature for one of these, we would have to do a one-for-one comparison with intaglio Jasper sources around Europe, because we haven't got a comprehensive database. If I can give you an analogy, the only reason people can test for DNA and tell you whether you're from the steppes, the Caucasus, or whether you're a Viking, is because there's a vast DNA database. Otherwise, it would be a case of comparing your DNA with somebody, Uncle Joe in Florida, and it's not going to work. Right, I think I've gone on long enough, and Sue's waving at me. So here's a summary of